Hi everyone, my name is B. Varun. I am from CSC D section. Today's my concept video topic is spectral matrices. The contents in my topic are what is a matrix, what is spectral matrix, formula of spectral matrix, and example. Moving on to the first slide, what is a matrix? The system of min to n numbers arranged in the form of m rows, each row containing n columns is called a matrix. It is denoted by A is equals to Aij m into n, where 1 is less than or equal to I is less than or equal to m, and 1 is less than or equal to j, and j is less than or equal to n. Now, moving on to the next slide, what is spectral matrix? The diagonal form of a given matrix is called as a spectral matrix. It is represented by alphabet D, and it is given by D is equal to P inverse into A into P. Moving on to the next slide, if lambda is equals to alpha, beta, and gamma, then D is equals to alpha 0, 0, 0, beta 0, 0, 0, gamma, where P is equals to x1, x2, x3. It is given by the set of eigenvectors of a given matrix A. Now, moving on to the next slide, example of a spectral matrix. Find the spectral matrix of a 3 into 3 matrix 1, 1, 1, 1, 1, 1, 1, 1, 1. Solution. Let A be the given matrix, then A is equals to 3 into 3 matrix 1, 1, 1, 1, 1, 1, 1, 1, 1. Then the characteristic equation corresponding to the matrix A is mod of A minus lambda I is equals to 0, where lambda is the eigenvalue. Moving on to the next slide, det of 1 minus lambda 1, 1, 1, 1 minus lambda 1, 1, 1, 1 minus lambda is equals to 0. On expanding the above determinant, we get 1 minus lambda into 1 minus lambda square minus 1 into 1 minus lambda minus 1 plus 1 into 1 minus lambda is equals to 0. By solving this, we get 1 minus lambda into 1 plus lambda square minus 2 lambda minus 1 into 1 minus lambda minus 1 plus 1 into 1 minus 1 plus lambda is equals to 0. By solving this, we get the equation minus lambda plus 3 lambda is equals to 0. Lambda into lambda minus 3 is equals to 0. Lambda, by solving this equation, we get the lambda values as 0, 0, 3. Therefore, the eigenvalues are 3, 0, 0. Let us find the corresponding eigenvectors. Let x is equals to x1, x2, x3 be the eigenvector corresponding to eigenvalue lambda. Then a minus lambda I into x is equals to 0. Moving on to the next slide. 1 minus lambda 1, 1, 1, 1 minus lambda 1, 1, 1, 1 minus lambda into x1, x2, x3 is equals to 0, 0, 0. Let us substitute lambda is equals to 3 in the above equation. Then we get minus 2, 1, 1, 1 minus 2, 1, 1, 1 minus 2, x1, x2, x3 is equals to 0, 0, 0. Let us consider minus 2, 1, 1, 1 minus 2, 1, 1, 1 minus 2. And we get the equations from the matrix minus 2x1 plus x2 plus x3 is equals to 0. x1 minus x2 plus x3 is equals to 0. x1 plus x2 minus 2x3 is equals to 0. Let the three equations be equation 1, equation 2, and equation 3. By solving any of the two equations, we get let x1 is equals to k1, x2 plus x3 minus 2k1 is equals to 0. Minus 2x2 plus x3 plus k1 is equals to 0. x2 is equals to k1 and x3 is equals to k1. x2 is equals to k1 and moving on to the next slide. Therefore, x1, x2, x3 is equals to k1, k1, k1 is equals to k1 into 1, 1, 1. Then by taking the k1 value as 1, then the corresponding eigenvector for lambda is equals to 3 is 1, 1, 1. Here we got one of the eigenvector. Let us find another eigenvector by substituting lambda is equals to 0 in equation 1. We get 1, 1, 1, 1, 1, 1, 1, 1, 1 into x1, x2, x3 is equals to 0, 0, 0. Consider 1, 1, 1, 1, 1, 1, 1, 1, 1. From this, we get the equation x1 plus x2 plus x3 is equals to 0. Solving the above equation, we get two solutions. 1, 1, 1, 0, 0, 0, 0, 0, 0, x1, x2, x3 is equals to 0, 0, 0 by doing R by doing row operations. R2 gives us to R2 minus R1, R2 gives us to R2 minus R1. Now, moving on to the next slide. Here we got the set of eigenvectors. Let it be matrix P. P is equals to 1 minus 1 minus 1 1 1 0 1 0 1. X is equals to minus k1 minus k2 k2 k3 is equal to minus 1 1 0 minus 1 0 1. Let us find det of P. Det of P is equals to det of 1 minus 1 minus 1 1 1 0 1 0 1 is equal to 1 into 1 minus 0 plus 1 minus 0 minus 1 into 0 minus 1 is equal to 1 plus 1 plus 1 is equal to 3. Let us find adjoint of matrix P. Adjoint of P is equals to transpose of cofactor matrix of P. Moving on to the next slide. Let us find cofactor of matrix P. Cofactor of matrix P is equal to 1 minus 0 minus into 1 minus 0, 0 minus 1 minus into minus 1 plus 0, 1 minus 0 minus of 1 minus 0, 0 minus 1 minus of minus 1 plus 0, 1 plus 1 minus of 0 plus 1, 0 plus 1 minus of 0 plus 1, 1 plus 1 is equals to 1 minus 1 minus 1, 1 2 minus 1, 1 minus 1 2. Therefore, adjoint of matrix P is equals to 1 1 1, 1 2 minus 1, 1 minus 1 2. P inverse is equals to adjoint of P by det P is equals to 1 by 3 into 1 1 1 minus 1 2 minus 1 minus 1 minus 1 2. Now moving on to the next slide. D is equals to P inverse into A into P is equals to 1 by 3 into 1, 1, 1, minus 1, 2, minus 1, minus 1, minus 1, 2 into 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 minus 1 minus 1, 1, 1, 0, 1, 0, 1 is equals to 1 by 3 of 900, 000, 000 is equals to 300, 000. Therefore, this is the spectral matrix of a given matrix A. Now, moving on to the next slide. Thank you, everyone.